Hello and welcome to this course. We'll take a look at Zensol's measuring instrument, the CbaWin by Zensol Automation, in collaboration with Hydro-Quebec. At the end of this module, the participant will be able to use the CbaWin circuit breaker performance analyzer. Lesson 4. Test execution and results analysis. What information should I check before starting a test with CbaWin? How do I check communication between the CbaWin and CbaWin? How do I run a cable test with CbaWin? How do I run a test with CbaWin? How do I save a test with CbaWin? How do I analyze signals with CbaWin? How do you scale in X, Y, or examine the value of a signal with CbaWin? How do I display tabular reports? How do I export to Excel with CbaWin? How to test displacement with a ZLR mechanical kit? How to test displacement with a ZMS mechanical kit? What information should I check before starting a test with CbaWin? In the worksite, the focus is on the blue buttons, which must be used in the order in which they are presented, that is from left to right. The first blue button lets CbaWin know the identity of the CbaWin you have connected to your computer. CbaWin thus recovers the serial number, year of manufacture, and specific characteristics of the product. If nothing is displayed, this means you have a first-generation CbaWin, and we recommend that you update its firmware. The serial number and test time are automatically displayed at the bottom of your graphical screen. For example, this information will let you know that the same circuit breaker has been tested with two different CbaWin. This makes the traceability required by ISO 9001 much easier to apply. By clicking on the Start button, check that the CbaWin information is correctly inserted in the boxes. The Notes section gives you some relevant information about your CbaWin. For example, if the test plan is compatible with the instrument, or if the instrument has the 0 to 1 amp range. The 1A range is a great addition to your CbaWin, especially for new circuit breakers, which draw very little current from the closing or opening coils. Above all, check that there are no incompatibility warnings. In this example, we know that the test plan is compatible with the CbaWin used, that it has the 0 to 1 amp range, and that optical inputs 89, 90, and 91 are active. How to check communication between the CbaWin and the computer? Click on the second blue button to check the stability of communication between the CbaWin software and the CbaWin device. In the bottom left-hand corner, you'll see the short communication tests. You must obtain 100%. If this is not the case, go to Appendix 2 of the installation guide entitled Communication Tests, where you'll find recommended points to check. How do I run a cable test with CbaWin? We move on to the third blue button, Cable and Circuit Breaker Test. This function is very useful for pre-test checks as it allows you to find out the status of circuit breakers remotely. It is also used to close or open circuit breakers. This function is also very useful for detecting faulty or incorrectly installed cables. Finally, it is used to determine the absolute position of analog displacement transducers. Click on Refresh. The left-hand side shows the status of cables and contacts. If it's green, it's open. If it's red, it's closed. If gray, the signal has not been activated in the test plan. The middle section checks analog inputs and connected resistive sensors. If it's white, the input is active. If it's gray, it's inactive. Ideally, resistive sensors should be around 50% to prevent them from dropping to 0. In this case, the analog inputs are grayed out and not activated. The right-hand section shows the status of the optical encoders. Here too, white is active, gray is inactive. In this example, only the first 3 optical encoder inputs are active. If, for example, you want to do a close test, but your contacts are red, this means they are already closed. You must therefore open them before running your closing test. You can do this by clicking on the Open button. The software will send an opening command without taking any measurements. After clicking on Refresh, the contacts should appear in green in this window. If the condition of the contacts is abnormal, check that the clamps are correctly installed on the contacts and that they are clean to ensure good adhesion. If this persists, change the input cable and see if the color changes channel. If so, your cable may have a problem. How do I run a test with CbaWin? Once everything is correct, click on the blue Running Man icon to run the test. You will be asked if you really want to run the test. Click Yes if this is the case. To move on to the next test, click on the blue arrow. then back to the running man to launch the next test, and so on. How do I save a test with CbaWin? Once you've completed your test sequence, save your work. Click on the floppy disk icon. In a situation where you see something special on the curves, record it. CbaWin may transfer your data to your technical support team, who will better understand the situation and know how to help you. How do I analyze signals with CbaWin? Here's an example of data from the KSO.wdt file in the CbaWin example directory. The graphical page previously configured in the test plan shows from bottom to top the closing coil current indicated by its software number 1. No signal for the opening current in number 2 because, as the title indicates, this is a closing test. Next, the displacement stroke according to number 3, then the virtual signal speed indicated by its software number 9 as seen previously. Then the 3 phase contacts. Phase A is connected to 17, Phase B to 19, and Phase C to 21. Note here that the user has used 3 separate contact cables, and in each cable he has used only the yellow clamp. Calculations for the various signals are shown on the right. How do I scale in X, Y, or examine the value of a signal with CbaWin? As mentioned above, the red buttons are used to analyze the various signals. To zoom in on the curves, use horizontal and vertical oak expansion. To zoom in on the calculations on the right, use the Lu icon. This slide shows the travel of a KSO indisjunctor displacement signal, amplifying X and Y. Per test, you can have up to 10 different graphic presentations. CbaWin calls them pages. Use the red arrows to move from one page to the next, and thus from one graphic presentation to another. This is particularly useful for 24 contact disjunctors in the 735 kV range to facilitate phase analysis. For example, in Hydro-Quoc-Beck's standardized drawings, page 1 shows all signals, page 2 phase A, page 3 phase B, page 4 phase C, page 5 displacements, page 6 speeds. The beauty of these universal test plans is that the pages are already pre-configured in the test plans, giving the operator the ideal graphic layout. How do I display tabular reports? To export as a tabular report, click on the large T icon. How do I export to Excel with CbaWin? Once you've saved your data as a WWT file, you can export it in Excel format. Just click on the large red X and they will appear in an Excel table. How to test displacement with a ZLR mechanical kit. The ZLR kit can be used to check contact displacement for a linear mechanism. This kit is marketed by Zensol. It is used with a rotary transducer, either analog or optic code, depending on the test plan chosen. It is very useful when space is limited for the large linear resistive sensors of the ZLR kit. The ZLR kit is secured by clamps. The mechanism's shaft turns the ZLR's wheels, producing a rotary motion measured by the rotary encoder on the other side of the wheels. Here's an example obtained on a GL315 circuit breaker B contact. To see the speed associated with the move, go to page C using the red arrows. The speed is shown at the top, followed by the displacement curve, then the contact closure time. How to test displacement with a ZMS mechanical kit. For a rotating mechanism, Zensol's ZMS kit is highly flexible and can be adapted to a wide range of situations. Fix the clamp on the circuit breaker, aim at the black arm which brings the rotary encoder into axis with the circuit breaker mechanism. The ZMS kit is a universal kit that includes a variety of bolts to fit different circuit breakers such as HPLs. It is used either with a resistive rotary encoder which connects to the analog inputs or with an aroptic encoder which connects to the aroptic code inputs. Here's an example of what you get on a phase A contact of a rotary circuit breaker. To see all measurements related to contact 1 and its speed, go to page 5 using the red arrows. The speed is shown at the top, followed by the displacement curve, then the contact 1 closing time. Question Lesson 4. How can I easily check that a cable is not defective using CbaWin? A, the blue man, B, the test link, C, the cable test. The answer is C, cable test.